TUnit is a promising .NET testing framework, but the question is how to build integration tests with it. Let's take a look. For that, let's use this simple API that basically has the CRUD endpoints for different operations working with an in-memory object. So you can see that we are posting to-dos, so tasks, and we also have methods to get them, to get a specific one, to put some changes, to delete them, and all of that using this singleton that has a dictionary for those to-do items based on the ID. So nothing fancy, but what we want to do is to simulate the process of building those integration tests from the outside, calling that API and seeing how you can build that using TUnit. Also, we'll take an extra step during the video where we will see how to take advantage of some amazing features that TUnit has that usually other testing frameworks don't have it. So stick till the end to see those. First thing that we need to do is to create a testing project. What do? Create a new project of the type console. So instead of going to the traditional unit tests and picking the testing framework that you want to use, you want to create a console application. Why? Because TUnit is so recent that most IDEs, I don't think there's any IDE yet that supports that out of the box. So here I will create my to-do API.tests. Once you have your testing project, the next step is to remove the program.cs. You will not need that. And one more thing is to install the TUnit package. Once we have that in place, we can start creating tests. So for example, I want to check that if I call the post endpoint, I can create a new to-do item. So I would bring a class. Let's call it to-do scenarios. And here I want to bring the test attribute to say this is a test. Then I need to have a test that will return a task. Okay, so in this case, it will be asynchronous. And I will say that it should return 201 when to-do created. Simple idea. Call the API, it should be created, we check the status code. But how do we call the API? The way that we usually do it is by using the web application factory, and here will be exactly the same. So the web application factory will bring an in-memory instance of your API, and we'll call that. Okay, so this is for the scenario where you are testing an API. If you are doing narrow integration tests, that is a type of tests where you do integration, but specific to the adapter against a database. If you want a video on that approach, please let me know. When you have something like that, you will not be using the web application factory, but you will be using something like a container or a given connection to a given database, for example. In this case, let's follow the process of testing an ASP.NET API. So what you'll do is that you'll install another package. For that, we need the Microsoft ASP.NET Core MVC testing. Add it to the project. And with this, I can now create a new class here on my tests that will be my API factory. So this API factory is responsible to build the instance of the API under test. So we can take advantage of the web application factory that is part of the package that we just installed, and we'll say, okay, this web application factory wants to start this given API. For that, we need to point to this to-do API. One way to do it is by bringing here the program class that you can find it out of the box on the program.cs, as you know, on the most recent versions of .NET. The other way that I like to do it is by using an interface. So I like to bring something that I call an API assembly marker. And why do I do that? Because by having a specific interface with the name assembly marker, I know that this interface has a goal. The goal is quite simple, is to represent this API when I need to resolve something from that API itself. So in something like this, I can now point to the API assembly marker, and I'm pretty sure that no one will drop this thing by accident. No one will go into the program CS and think, why are we having here explicitly the public class program, all of those things. So with this, now we can bring our API, right? So we could go into our scenario and we would create a new factory. So new API factory. That factory gives you access to create a client. The client is an HTTP client. So var HTTP client is equal to that. Having the HTTP client, that means that now we can call the API. So we could go into HTTP client dot post async, and we want to post the object for the to-dos. So we can also use the posts as JSON async, because that way it will be simpler for us. So we could come here and say, okay, I want to create a new to-do with this title. So now we can await for the response, set that response to a variable, and finally we can do the response dot status code, and we can assert that status code. By using simply TUnit, we can use the assertion library from TUnit and do the assert that the status code is equal to the HTTP status code created. And this needs to be awaited. By the way, to run this test, you need to go to your IDE, and if you are on Rider, you will go to the same place as I am. Otherwise, make sure that you go to the documentation and you'll find the instructions. So here, I need to say that I want to enable the testing platform. By saving this, and once you restart your IDE, now you can run the tests. Why? TUnit is based on a new platform for testing. It's not on top of the previous infrastructure for testing that existed in .NET. So you need to say to your IDE that it needs to look for the tests in a different way. That's why we set that setting. So now I can go here, go to my testing window, and you can see that it now finds the tests that exist. So if I run the test, it goes through. But now let's say that I want to test another scenario. I want to test the scenario where I create a to-do item and I can remove it afterwards. So I could come here and say, it should return the 204 when delete existing to-do. So that means that we need part of the same thing. So we need to create a to-do item, but then we'll need in the response to get the ID from it. So we can get the created object. And once we have that, we can now call the API. So we do the await, HTTP client, delete async, to-dos, and we'll provide here the created.id. Now with the response, we can go and assert that the status code is equal to no content, so the 204. So let's run those tests, and they will be executed in parallel. But now notice the following. On each test, I'm building the infrastructure. So I'm starting the API, creating the HTTP client, and calling it. They are running in parallel. That's fine. Just two tests, not a big deal. Database is in memory, no problem. But what if this thing is something serious and it takes some time to start everything? I want to optimize this. So I want to bring the API factory into a shared context. So I don't want it to be created per each test. If I move it to the constructor, it will still happen. So how can I do that in TUnit? How can I do something similar to a test fixture, something like a class fixture or a collection fixture on XUnit? How can I do that here? So for that, TUnit has one feature that is called the class data sources. What does that mean? It means that you will define an attribute that will say, please inject this class here. And you can do it in places like, for example, a method or into a property. So we could come here and say, I want an attribute class data source. what's the class that I want to be injected? The API factory. And now I will say how many times. For that, I can use this shared type. And on the shared type, you can instruct this class data source how many times it should create a new instance. Basically, is that. So you can say that this is not shared at all by saying the none. You can say things like the keyed. That is quite interesting. You can define a string and say, okay, when I share the same string, use the same instance. On this case, let's use the per test session. So that means that once I execute this, it will only resolve this attribute once for all the tests executions. So I run the tests, it's a test session, all the tests we executed during that session will share the same instance. And what do I do now? I need to assign this API factory to somewhere. And that can be something like this. It can be something as simple as assigning it to a static variable of the type API factory, give it a name, and that means that now our tests, instead of creating it every single time, they can use the static variable. And now it only creates it once. But now let's say that I want to reorganize these tests and I want to have a test class only for the create, a test class only for the delete, or my API has different types of scenarios, so I want to segregate them in different test classes. So let's say that I duplicate these to-do scenarios, and I will create a to-do delete scenarios, rename it, remove the create scenario, and also go to the to-do scenarios and rename it to to-do create scenarios. And let's delete the scenario for the delete from here. So I still only have 2 tests, but I have to do this in every single place because in every single class I will need this API factory. So one way to do this in a smarter way is by creating a new class. Let's call it API test base. And this one can be an abstract class. That means that now I can bring this into there, and my tests simply need to implement the API test base. So I simplify this scenario, and also I can implement exactly the same thing on the other one. And basically by doing this, I'm just saying all those tests run in the same context. They share the same fixture, they share the same state, the same instance of the infrastructure that I am creating for the sake of testing. So with this, you can build what you usually do for the sake of integration tests through the API. But there are other things that you can do for the sake of integration tests that are quite interesting, taking advantage of some interesting features on TUnit. So one of them is regarding this thing that you'll see here. On the put endpoint, we have a delay. So it might take from 0 to 10 seconds to execute the code of the update. This delay is here to simulate an API that is unstable. Okay, sometimes takes more time to run. And you don't want to block your tests for a long time for them to run. So you want to define something like a timeout. And while you can implement that nowadays with other testing framework, TUnit has one way to do it quite simply. So let's bring a test for that. We can have a test, something as simple as this. We create our post, right? Then we do the deserialization to get the one that was created because we need the ID. I will create an object that is basically the response with an updated title, and then we'll put that new version. So what I want to do is to check that the updated was okay. So when we run our tests, we can see that, okay, it was executed with success. It took 6 seconds. So we run again, 9 seconds. So this is not the type of experience that you want to have on your tests. So you want them to be fast. So if you want to define something like, this is only successful if it took a given amount of time, less than 1 second, let's say less than 2 seconds, how can you do that? So TUnit has this concept of timeouts. So you can define simply with an attribute that you want to define a timeout for that test to execute. So let's say that I want it to take 3 seconds, for example. You can add it here, and that will give me access to a cancellation token that also I can pass to the different methods that can accept a cancellation token. That way, once it's finished, I can cancel that request as well. So if we run the test, we can see that the test was timed out after 3 seconds. So if we run again, this time will go through because it only took 1 second. So you can see how it works. You can define just with the timeout here your expectation. Okay, this is only successful if it takes under that given amount of time. What is extremely useful and quite simple to implement when compared to other approaches. And there's one feature that can be extremely useful for scenarios where you do something like an end-to-end test, and it takes a lot of time to build all the steps, and you don't want to have several tests repeating the same logic. This feature can be extremely useful, but be careful to not overuse it, because in some scenarios you will lose that good property of a good test. That is, the tests are independent, they run in isolation, you have the test self-contained, and you can see the description of everything that should happen for that to be a success. So I think this approach that I will show you is quite useful to something like an end-to-end test, but not as good for the other types of tests that we usually build as integration, as unit tests. So let's see how to do that. So let's take a look into this example. It's an end-to-end test that, let's say what we are doing is, let's post something into the storage, and then we want to check that when we get the list, we can get the to-dos from that response, and it shouldn't be empty. So that thing should be there. This is just a small test, but now you can see where this thing can go. It can go to something like, I create a client, then I post an order, then I check the status of the order, then I need to perform a payment or something like that. A lot of steps of the workflow, and I have a long test for that. So in this case, what I can do with that feature that I will tell you is that I can split this test in two. So let's say that I have a should create and should have to-dos in list. So the should create will only be responsible to create the to-do. Then the should have to-do items in the list will only be responsible to get the to-dos. But by having things in this way, that means that if this test doesn't run before that one, it might be empty. This is where this feature that I will show you plays a part. So with TUnit, you can come here and say that this test depends on, and you provide the name of the other test. You can do it this way, or you can simply say it this way. This test depends on the should create. That means that TUnit will enforce that this test only runs once this one is executed. So it means that there's a sequence. They can't run in parallel. They will run always one after the other. So that means that if we execute specifically this one, the have to do's, in fact, it will run the other one. So you can see that in my previous run, it took 70 milliseconds. And if I run the other one, it was updated because it had to execute it again. So it's a good way to organize those huge tests when you have something like end-to-end tests written with C#. It can be quite useful. One last thing that can be extremely useful is another attribute that you can use. For example, in this case of the timeout, you can say, let's retry this 3 times before saying that it was not successful. So if we run the test, now we can see it took 4 seconds, but we have a timeout of 3 seconds. That means that the first attempt failed, and then we used 1 second more to perform the second attempt, and this time it went through. So this is not ideal for every single type of scenario where usually a test might fail, because you might be hiving a flaky test, and you should address those flaky tests. But if you have something like an end-to-end test against the real infrastructure, and you might need to have this type of retries. It can be useful. So if you want to have access to this source code, you can find the link in the description to get it for free. And if you have any other thing that you'd love to see how to do it with TUnit, please let me know in the comments. And if you want to know a bit more of what TUnit is, I have this video right here where you can see my first attempt of using it while I was exploring it, while I was having my first contact with it, and how impressed I was at the time when I start seeing the types of things that it can do.